Hi, I hope you're here for Safe-ish by default. If so, you're in the right talk. As he said, my name is Philip. I am whoa, it sounded weird. I am a senior software engineer at Eventbrite. I've worked at Eventbrite for about 4 years. Currently I work on the discovery team, but over my time there, I've worked on a whole bunch of different things that are security related and full stack application development related, and our stack is entirely Django in the background. It's Django with MySQL holding our core data, and our front-end stack is a mix of various JavaScript things, but we are a Django Python shop. So if you're interested in that sort of stuff, please do come talk to me after the talk. I'm also incredibly lucky to get to work with Andrew Godwin and Simon Willison, both of whom are speaking here, both of whom are very heavily involved in the Django community. Simon spoke yesterday about Elasticsearch. Who was at Simon's talk yesterday? Yay, great, fantastic. And then Andrew is giving a talk this afternoon on Django channels, which is a really exciting project for getting some real-time response aspect into Django. And so I work with them, and as I was putting this talk together, it occurred to me that both of them are way more qualified to give this talk than I am, but this talk came about because there were a series of security meetups that were happening around the Bay that needed speakers. Django security is a subject that I'm really passionate about and really interested in, so I put a talk together. And they've both seen it and reviewed it and seem to have no problem with it. And I mentioned that not as some sort of false modesty, it's more to hopefully encourage all of you here, if there is a subject that you are interested in. I didn't know most of what's in this talk before putting this talk together. Like, I knew bits and pieces, but we're gonna go deep into some of how Django provides the security features it provides, and that I didn't know before putting this talk together. If there's a topic that interests you, it is totally within your grasp to learn about that topic and submit a talk for PyBay next year, for PyCon next year, and I totally encourage you to do so. If you're interested in learning more about that and tips for giving talks, feel free to come talk to me afterwards. And so today we're going to talk about Django security. We're going to talk about it through this lens that probably a lot of people here are really familiar with, where a friend who may or may not be technical comes up to you and says, I've got this great idea for a startup. How many people have heard this from someone before? I've just been like approached on the street saying, hey, I've got this great idea for a startup. Can you write it for me? Yeah, me too. So we're running with this idea, and we're going to say that a friend has come up to you and said, I want to start this amazing book selling site called Bezos Books. It's going to be a site for selling books. Authors are going to have a form where they can put in the book information they're trying to sell. That book information is going to get rendered in HTML to a book page, and there's going to be a form on the book page where people can put in credit card information in order to buy the book. So it's author to reader direct sales of books. And you, being a savvy developer, are going to use Django to build this site. And you go forward, you work with this friend, you decide he's got a good enough business acumen, some savvy that you think it could be a success, and you present him the basic version of this site. And he says, that's great. Is it safe? And you go, well, it's kind of safe-ish. What does safe-ish mean? So the reason this talk is titled the Django Security Model, safe-ish by default, is that first of all, there is no such thing as perfect security. The only perfectly secure system is a system that is off, preferably off and wrapped in duct tape and in a box and in the bottom of a river. That is a perfectly safe system, except from Rust. But all other systems that are, especially systems that are connected to the internet, have some security flaw, whether or not you've realized it yet. And this goes doubly for web applications, because web applications live on the web and they are exposed to the entire internet potentially. And so I call Django safe-ish because what Django is trying to do is provide sane defaults for developers out of the box. It's going to try to make it as hard as possible for you as a developer to shoot yourself in the foot. And it does this by trying to mitigate some really common attacks. One of the attacks that it tries to mitigate is cross-site scripting. Cross-site scripting is often abbreviated as XSS. In an example of the first time ever that people didn't choose a conflicting acronym for a name of something a computer science topic, CSS was already taken, they chose XSS. We should be very grateful because our lives are hard enough already. And how do cross-site scripting attacks work? What is a cross-site scripting attack? If we go back to this site that we've built, where authors are selling books directly to readers, we theoretically let authors put whatever they want in like the book description field or the book title field, and then that gets rendered to the page as HTML. If Django were vulnerable to cross-site scripting attacks, what would be possible is an attacker could write some JavaScript into that book description field, into the book title field, and Django would just render that JavaScript straight to the page. And that may not sound bad until you realize that that means that if the user is logged in and has cookies, if they have saved credit card information, if they're entering credit card information to buy a book, JavaScript gives you access to anything that's going on within that page in the browser. And as a developer, you want to make sure that only the scripts that you want are running on your site. So cross-site scripting is allowing arbitrary things to run on the browser page that the user is seeing. And so what you'll notice if you try to put JavaScript into a Django page and then render it normally, it'll turn something like script alert hello script into this kind of gobbledygook looking thing of HTML entities, where what will get rendered, the browser will see this and render it as script alert hello script, but it won't execute it because it's translating these entities into something that looks like readable text. Now, this talk is going to try to go into how Django does some of these things. And what's kind of remarkable is there's this principle in Django of doing the least amount that will get the job done. And this is going to be really important in the next topic that we cover. But this is the actual code from the Django codebase that does all of the heavy lifting for escaping text. It's just string replacements, right? I say just, I mean, that's not necessarily a great word because just implies some things, but all it's doing is string replacements. And that's really powerful. It's not trying to catch certain tags or try to do tag parsing. It's just like, if I encounter one of these symbols, I'm going to return the HTML entity so that the browser won't try to render it. Now, of course, if we want to, we can turn this off. Django provides mechanisms for saying, I think this string that I've put in this template or I've rendered from this view is safe, and you should not be doing any string escaping on it. And that's through the marksafe functions and the pipe n and the pipe safe. Marksafe is what gets used in a view, and then pipe n and pipe safe get used in the template tag itself. The next thing that Django protects you from is CSRF, or cross-site request forgery. Come on in. Water's warm. Or not. OK, what are CSRF attacks? Going back to our example, we have a form that lets users put in their credit card information in order to buy books. We additionally have a form that lets authors manage their inventory of books. Like they can add new books, they can edit books, they can delete books on their site. And all these are happening through form posts, right? A user's putting in some information in some fields, they're clicking a submit button. That form is making a post request back to our site. Now, there's an anecdote about why cross-site request forgery is important. And that anecdote is that about 10 years ago, Google was trying to do this thing to speed up page speed loads. So they would prefetch pages for you. And at the time, developers weren't very aware of cross-site request forgery. It hadn't really matriculated into common knowledge. And so they weren't protecting the form submissions so that anyone could basically submit those forms. And so what would happen is Google would try to prefetch all of the delete links for all of the blog posts when people were logged in as admin, and all of their content would get deleted. That's trying to explain how cross-site request forgery works, where a cross-site request forgery is somebody submitting a form or submitting an endpoint to your site that you don't want to actually be submitted. And so CSRF protection is adding a token to the form body when it gets posted to make sure that the exact person that you want to be submitting the form, or at least the exact browser you want to be submitting the form, is the actual person that is submitting the form. That was a lot. It's kind of a convoluted example, but you're trying to protect and make sure that only the person, the browser staring at the site right now is submitting a form, and that all other form submissions get rejected. That's kind of the big overarching picture. And the way that Django accomplishes this is with a piece of middleware called the CsrfView Middleware. And the way that works is when you make a request against a site that has a Django site that has the CsrfView middleware in place, and that the CsrfView middleware is in place by default, so unless you've deliberately turned it off, which I don't recommend, all of your Django requests are going through the CsrfView middleware. It's going to set a cookie on the response that is the CSRF token cookie. Additionally, how many of you have written Django forms and noticed that you need to put the little like template tag for CSRF token like at the top of the Django form? A couple people? Great. If you go through the Django tutorial or if you're writing Django forms, you'll often notice that you open the form with the post endpoint, and then you have like the first thing is normally CSRF token. And then you put the rest of your form and you close the tag, have a submit button, all of that. And what that CSRF token is doing is you're asking Django to embed the CSRF token in the form data that you're going to be submitting back to your view. And so what Django does is if the request is a post, it gets the CSRF token from the cookie. It gets the CSRF middleware token from request.post from that form you just submitted. And if they match, then it lets everything go through. And if they don't match, or if one is missing, then it rejects the post and the form is not submitted. So it's comparing something that's in the cookie with something that's on the page and making sure that both match so that Django can say, this session, this browser session that was looking at the form is what actually submitted this form. Now, like with the previous example, there is a way to get around that, and that's with the CSRF exempt decorator. This is the actual code of the decorator. Did you have a question? Sure. Let's save questions for the end if that's okay. Yeah, great. I have a feeling there's going to be quite a bit of time for questions, so let's save questions for the end and hopefully we can answer it then. So this is the actual code of the the CSRF exempt middleware, which you can put on class-based views and function-based views to exempt your entire view from the CSRF middleware. And you notice that all it's doing is it's scrobbling onto the wrapped view object and setting CSRF exempt equals true. Very simple. And so really, we need to update our code to say if the request is a post and the view is not CSRF exempt, then we do the comparison and proceed. And so you might be asking, because I know I asked, when is there a time when you wouldn't want when you would want to make something CSRF exempt, because it seems like you would always want to be certifying that it's the same session submitting the form. The best answers that I've seen so far are if you are having a log out view that you're maybe sending from a different part of your site, you might want to make the log out view CSRF exempt because it's not going to do anything necessarily damaging to the user. It's just going to log them out of their session, which is annoying, but not like the worst thing in the world. But anything where a user is doing a potentially like data changing action, you really want to make sure that that has CSRF protection, because if you don't, anyone on the internet could theoretically be changing your user's data if they have control of a different browser session. Again, Django does this out of the box for you, which is fantastic. So quick side note about cookies. I mentioned that the CSRF middleware, the CSRF token is stored in a cookie on the session that gets set by the CsrfView middleware. Now, if you look at that cookie, this is a bit higher level, but I think it's an interesting example. You'll notice that that cookie is not set HTTP only. When you set a cookie on a browser session, there's a whole bunch of properties you can set. You can set, cookies are basically key value stores. So you can set a key, you can set the value, which is some length of data. You can set an expiration time. You can set whether it's secure, and you can also set this special field called HTTP only. And that HTTP only field is there to prevent the DOM, so like JavaScript or things within the page, from being able to read the cookie. HTTP only is you telling the browser, hey, hold on to this and send it back to requests, but don't let anything in the page actually access it. And you might think, well, isn't that what we'd want? Like, we don't want rogue JavaScript messing with our CSRF cookie, then somebody could make an attack against our site. And that's true. There's a couple reasons why the Django CSRF cookie is not HTTP only. One is kind of a practical. If someone has the ability to run rogue JavaScript on your site, then game over. Right? Like, you're already vulnerable to cross-site scripting. If somebody changing your CSRF cookie at that point, like they're going after weird low-hanging fruit, they could get much higher fruit off your tree. It's less of a concern. The more interesting reason is that by having the CSRF cookie accessible to the page, accessible to JavaScript, that's how you can authenticate posts using jQuery AJAX or some other AJAX method. If you've ever set up jQuery AJAX, you know you do that like $.AJAX setup thing where you pass in the CSRF token. You're normally pulling that CSRF token from the cookie that's living in your browser session, and if that cookie was set HTTP only, you wouldn't be able to access it. That was a little side note. It was maybe higher level than the rest of this talk. That's fine. Hopefully you got something out of it. If not, that's totally okay. Okay, so this is, in many ways, the big one, SQL injection. What is SQL injection? SQL injection, I can hopefully demonstrate by example. So we mentioned that we have a page that shows books. Author submits a book, we create a little page for the book where people can buy the books. Let's pretend that the URL for that page is something like bezosbooks.com/book-title. Right? If you have built a lot of web applications, that style of URL where it's like a couple of words dash separated is often called a slug. So if we pretend that we've turned the book title into a slug, and then we are fetching the book out of the database by that title, the model kind of works. Now, if we had written our book fetching code, the code that fetches the book from the database directly, and weren't using the Django ORM, and we're just like deslugifying the title and just fetching straight from the database, just putting that value right into like select star from books where title equals book title, then we have opened ourselves up to a SQL injection attack, because someone could put arbitrary strings that look like SQL commands, like say drop table books or drop table users or select star from user.password, and potentially get compromising information back from the database, or potentially destroy our entire database. Both of these are really bad. And so what Django does out of the box is it has an ORM. Hopefully people are at least roughly familiar with the Django ORM. You've noticed that you wouldn't do, select star from books where title equals book title. You would do book.objects.get title equals book title. Hopefully that sounds a little familiar. And what's happening there is you are separating the data, which is book title, and the code, which is what's fetching the objects from the database. And so when I was looking up this talk and diving into the subject, I was looking for the point where Django did the string escaping to try to make sure that the strings that it was passing into the database were correct strings, that they weren't going to muck with the database. And it turns out that following the principle we talked about earlier, where Django does the least amount of work to get the job done, Django does none of that. What Django does is it doesn't screw it up. And it's surprising how hard it is to not screw it up. There's a quote from Alex Gaynor, who some of you may have heard of: "Don't ever confuse code and data, it's the key to happiness." Django keeps that data, the title equals book title, and the code for fetching the book from the database separate all the way through to the database driver. And then it's the database driver's responsibility to do SQL escaping and to combine them in a safe way so that you're fetching things back from the database sanely and safely. And that's great because it means that the Django developers don't have to be experts on database escaping or SQL injection. They rely on the database driver maintainers to do that. They just have to not screw it up. And so if you're using the Django ORM, again, there's no such thing as perfect security, but I have never been able to successfully get a SQL injection attack through the standard Django ORM. Now, of course, There are ways to get around that protection built into the ORM. So if you're using one of these, .extra or raw SQL, where you can just kind of pass in arbitrary SQL commands to the Django ORM, which are then going to get run straight against the database, you can totally open yourself up for SQL injection attack. This is very much not recommended. There are going to be maybe some cases where .extra or raw SQL are needed to get kind of around the limitations of the ORM, but there is an open call from the Django core developers that says, if you think you have a case where one of these are needed, come talk to us. We want to make it not needed for that case. They want to provide you more protection. These are there as kind of safety latches for right now. Okay, that's SQL injection. We're gonna take a little break. It's a lot to cover really fast, but we're getting close to like making this better instead of just covering what Django's doing for us. Okay, clickjacking. Clickjacking is a bit of a weird one. Clickjacking I put into a similar category as like phishing attacks, where someone is going to load your entire site in an iframe on a different domain and then be able to run some JavaScript on the parent DOM to track all of the clicks and all of the text input that a user is making into something that looks like your site. So as an example, I work for eventbrite.com. If somebody else registered like eventbyte.com and iframed our site and then started sending out links to it, if we didn't have clickjacking protection, then that person could be capturing usernames and passwords and credit card information for all of our users, and that would be incredibad. Luckily, like with most of these things, Django does protect us against this through something called the X-Frames Options Middleware. And what the X-Frame Options Middleware does is set another property on the response to tell the browser, hey, do not load this site over iframes. Please, please, please don't load the site over iframes. Now, you might notice, we have to ask the browser to hopefully respect this. And unfortunately, not all browsers respect the parameter to protect you from clickjacking. It's most browsers. I mean, that's going to cover the large majority of your users, but there are going to be some users who are still susceptible to clickjacking because the browsers don't support the property to prevent against it. Like with all things, you can get around this clickjacking protection by using X-Frames Options Exempt, X-Frame Options Deny, X-Frame Options Same Origin. They give you a lot of flexibility. What I can say is I've been developing Django for like 6 or 7 years. I have never really had to mess with the X-Frame Options anything. You may have a use case where you need to be loading your site over iframes. At that point, please don't turn off the global clickjacking protection. Go through view by view and make sure you know exactly which ones you need to iframe. Okay, we're getting there, getting close. Host header validation. So how many of you have tried to deploy a Django site and realized you left the debug on? Just me? Oh, come on. Yeah, okay, thank you. A couple honest people in the back, great. How many of you, and I'm gonna be guilty of this too, have realized, oh crap, I left the debug on, so you turn the debug off, and then you see you get, 400 bad requests. Yeah, a couple honest people, yeah, that's great. And the reason you're getting that 400 bad request is Django is doing something called host header validation. If you've turned debug off, Django assumes that you're running in production mode, and it's going to try to deny any host that you haven't explicitly told it, hey, this is an okay host. So that allowed hosts setting that you needed to adjust in order to make the request not a bad request, Django is checking that list of hosts through a function called getHosts with every request to see if it's an okay request. And this is protecting you from the idea that if your web server is just kind of open or maybe misconfigured in some way, and you think you're serving eventbrite.com, but it turns out you're also serving eventbyte.com and you only want requests from eventbrite.com, then if eventbyte.com isn't in your allowed hosts, then it'll get a bad request and your users will be protected. And so the algorithm looks a little bit like this. This is obviously a simplified version, but that's all it's checking. Does it have a domain? Is that domain in allowed hosts? Great, move forward. Otherwise, throw that bad request error. Cool. 2 more things that Django is doing for us to help us out, and then we're going to talk a bunch about how to make this all better. First is sessions. Sessions are cookie controlled by design, so when you hit a Django site for the first time and you go look at your cookies, you're going to see a couple of cookies. You're going to see the CSRF middleware cookie that we were talking about earlier, and you're going to see a session cookie, which is how Django identifies the session that you currently have. They're cookie-based by design, which means that as a result, you could have cross-domain session leakage if your cookies aren't controlled. This is kind of an esoteric topic, so I don't dive into it, but just be mindful of what cookies your site is setting, because Django actually makes it pretty easy to just kind of like arbitrarily set cookies on responses. Be mindful of what you're setting. And then let's talk about passwords for a minute. This one's really cool. Django does actually a really good job storing passwords as is. And what's cool about it is Django ships. So the way Django stores passwords, you as a new user create a password. Django salts and hashes that password, stores the salted hash in the database. Django never again sees the clear text of the password. Every time you now log in, it is re-salting and hashing the thing you just entered and comparing it against the stored salted hash in the database. And if the two match, great, you can log in. But Django does not know what the clear text of your password is. Not only that, Django ships with some really good algorithms for salting and hashing passwords, but you can do automatic algorithm upgrades. And the first time I heard about this, I thought it was kind of magic. Wait, if it's salted and hashed in the database, how can I upgrade to a different cryptographic function? That makes no sense. Here's how Django does it. Django has a list in your settings file of algorithms that are allowed to be used for passwords. If you want to add a new one, you add a new one to the list. And when Django is trying to authenticate a login session, it will try to it will try to salt, hash, and compare with all of the hashing algorithms it knows. If it finds a match, but that match is out of date from whatever you say the most current one is, it will re-salt and hash with the updated algorithm and replace it in the database. So each time a user logs in, if I haven't logged in for 6 months and yesterday you changed the cryptographic hash that you want to use, I will get an automatic password upgrade the next time I log in. And that's really cool because it means that as new algorithms are discovered or exploits in old algorithms are found, you can just keep giving your users the most protection that you can. That lives in Django contrib auth hashers. Unfortunately, I don't have that on the slide. That would have been helpful. Leave me feedback. I'll put it on the slide. Also, that I do check that hashtag, and that's my Twitter. Probably should have announced that at the beginning. Whatever. Cool. So that is a very fast, hopefully not too long overview of what Django is doing to protect you. How can we make this better, right? It's safe-ish by default, the Django security model, and how can we make it better? The first one, and I'm going to cover the mic because I have to yell a bit because I have to get into my who here has read Harry Potter, especially the third book, or seen the third movie? Right? Yes, that's most of the room. Okay, so you remember the character of Mad-Eye Moody? Prep yourself for this. Constant vigilance! Honestly, there's no such thing as perfect security. You're not going to write code that you can guarantee is never going to have bugs. So the best thing you can do is, if you are the person who cares about security at your company or on your project, or if you have been tasked with improving security across your product, be vigilant. And the best way to be vigilant is to, 1, be doing code review, and 2, make sure that you have rules set up in your code review platform that will help catch things that could be insecure. So here's where I talk about some examples. Eventbrite uses Fabricator, which is, among other things, a code review tool that was originally developed at Facebook. We use the open source version. And it allows you to set rules on code reviews so that if something in a code review can trigger certain conditions that then alert the security team. So as an example, we have security rules written for all of the escape hatch functions that I talked about earlier. If someone writes code that has mark safe or pipe N or CSRF exempt or the clickjacking protection, everyone who has listed themselves as a security reviewer gets added to that review, and we then have to go approve it before it can move forward into the general code base. And Fabricator also allows you to do audits that work the same way, which if a piece of code lands that triggers one of these things, it gets a double check from the security team to make sure that we think it's an okay use of these escape hatch functions. Now with Fabricator, you can totally write a, like, if your team is pull request based off of GitHub, you can write a little pull request bot that will do the same thing. It just needs to scan the body of the code that's being submitted and look for those escape hatch functions. But I can't stress this enough. Those escape hatch functions are there because the reality of development is sometimes you need them. Try your hardest not to overuse them and not to let your team overuse them. The next thing that I hope everybody is doing, even for development sites, if you can, is HTTPS. It is 2016. We have won. There is Let's Encrypt. HTTPS is available for all. So please, please, please use HTTPS. Do a little bit of digging in what the correct settings for your HTTPS should be, because poorly configured HTTPS is unfortunately just as bad as no HTTPS, and occasionally worse, because you might be convincing your users it's secure when it's not. And what do I mean by correct settings? I mean, you know, SSL v1 and 2, you really shouldn't be using them. There's an argument you shouldn't be using SSL at all and should be just TLS. Make sure that you do some research and figure out what's going to be best for your users and use the most modern one. Additionally, if you can, Django has a setting that is secure_SSL_redirect. That works very similarly to the domain functions that we were seeing earlier, where if you set secure SSL redirect, and somebody tries to come into your site over HTTP, it will automatically redirect that site to the HTTPS version of that URL. I highly recommend you set that if you can get away with it. Again, there might be special cases where you need to allow access to your site over HTTP. If you really think you have those, come talk to me. Maybe I can convince you don't. Cool. CSP reporting. This one's also kind of neat. Content security policy reporting. Basically, that's the thing that a lot of browsers are starting to, I think most modern browsers included at this point, and it's where you can, on your site, submit, say, a policy that says, I only want to allow remote assets like JavaScript, CSS, images from these domains. And you can choose whether to block them or just to log them. And if you set it to log, then then the browser will send data to some endpoint that you choose saying, hey, this page loaded this time, tried to load assets from this site, but it wasn't on your approved list. What's going on here? What's really amazing about this is, one, you can just block things altogether and make your site really locked down and more secure. But if you're not ready to do that yet, how many people have gotten the HTTPS mixed content warnings? Yeah, great. I'm trying to be audience participatory. It's only kind of working. The browser can report to you where you are loading things that might not be over HTTPS. And then you can go track those down and fix it and fix your mixed content warnings. And that is a glorious, happy day for everybody. As an example, Eventbrite has our CSP currently set to log only because we're not quite yet at the point where we can completely lock it down. But we log all the CSP violations. They go into Splunk, and then we review the Splunk logs every once in a while and say, oh yeah, this site, we should lock that down. Or, oh, actually, this is something we own. We should change that to be HTTPS. And it's helping us get better over time. Another thing that we make heavy use of is a package called Django encrypted fields. This is trying to solve the problem of you having data at rest, so sitting in your database that you want to be secure because it's personal identifiable information from your users. We use it at Eventbrite because we do store some personally identifying information. If you are storing sensitive information, I highly recommend you use it. You are going to run into a problem, and the problem you are going to run into is, wait, I need to store the key somewhere. Where do I need to store the key? Somewhere that's secure, but then I need another key to access the place where the key is stored. So key storage is outside the scope of this talk. It's turtles all the way down, but we have some thoughts about it at Eventbrite. There are some cool tools out there. Come talk to me afterwards. Django Secure. Django Secure is a package that I still recommend installing, even though, and this is the great part, most of the things that Django Secure does have already been co-opted into core Django. So what Django Secure was doing when you installed it was automatically setting some settings for you so that your site would be more locked down. But most of these have just been kind of incorporated into the default settings file of Django. And that's one of the other reasons that, I guess I'm pitching Django now. One of the reasons that I as a developer really like Django is the team is always trying to make the out-of-the-box developer experience better so that I can be reasonably certain I'm deploying secure sites when I'm just using out-of-the-box Django. Pony Checkup is this really cool site. It works for almost any site, but it works especially well for Django. You go to ponycheckup.com, you put in the URL of your site, and it says, oh, here's all the basic security things we think you're passing. Here's all the things we think you should fix. That's really cool. Like with everything, no such thing as perfect security. It's not going to catch everything, but the glaring errors, it's going to help you find the glaring errors and help you fix them. This talk was inspired by a talk from DjangoCon last year, not this year, but last year, called Making Django Ridiculously Secure, where this talk is getting into the nitty-gritty. Kelsey's talk is talking about threat models and how to gauge how much you need to care about security for your product. So I wrote this talk to be a prequel to hers. I highly recommend you go watch hers next. She also gave a follow-up talk at PyCon this year that's online that unfortunately I don't have the link for. Also highly recommended. She has a unique case where she is building a really excellent product that is supposed to help victims anonymously and securely report sexual assault on college campuses. And so she has this incredibly wide attack profile that most of us don't have to worry about, which is like, what if I have to be sharing the computer that I'm reporting on with the person who is also my attacker? That's not a thing that we really have to worry about at Eventbrite, which is great. But so she's going to talk a lot about threat modeling and how to determine where your risk is. And then hopefully I've given you some tools to then lock down your risk profile when you get there. Yeah, and I think that is going to do it. And I will open it up for questions. Whew, that was a lot. Feel free to take a breath. I can put back on Heya if we need a palate cleanser. But also feel free to raise your hand. I think this lovely guy's got a mic.
Hey, thanks.
Sure.
I'm new to Python Django, but we have the only access pattern on our app is through mobile.
Okay.
And we use Django to manage our sessions, and we
Sure.
use cookies. And we noticed that one of the biggest errors in our system is just people's their cookie expiring.
Yeah.
And they're being not authenticated, and then we have to make them log in again.
Right.
And I'm wondering what you think are the best practices for that. Should we increase the cookie expiration time, or should we somehow auto renew it on the server and send them a new cookie? Any advice there?
Yeah, totally. So there's a practice that is going around the web right now that I really like. So there's kind of two approaches to this, right? On the one hand, there's what I call the Gmail approach, which actually annoys me, and I can get into why. But the approach is this computer is going to be authenticated for 30 days. We will not ask you for a password for the next 30 days, right? But 30 days are going to come up, and Gmail is going to log you out, and you're going to be sad because you have to log back into Gmail, and you're like, crap, what's my password? Oh, right, it's one password I have to, anyways. There's another approach, which I'm going to call the GitHub approach, although a lot of sites are taking that, which is your session is going to be good forever. But any time that you need to do something that could potentially be changing your personally identifiable information or changing your account in some meaningful way or taking an action that's going to cost you money, we are going to force you to re-authenticate your password. We are in the process of trying to explore that for Eventbrite because it's a model we like much more, that your base session never expires. But anytime you need to take an action that could be damaging to your account or to you as a user, you have to re-authenticate just to prove that it's you. Does that make sense? It's kind of you've got two models there. The thing that you suggested that I don't recommend doing is just kind of magically re-authenticating on the server, because there's just a lot that could probably go wrong with that. And it's better, it's annoying that users have to re-log in, but that's still keeping them protected. The GitHub approach means that they're maybe less annoyed, but it's if they're changing their billing information, then absolutely you need to prove it's them. And the best way to prove it's them right now is through some sort of password. Does that make sense? Great. Other questions? You had a question over there early, yeah. That's fine. Nobody else is raising their hand.
It was just for the CSRF middleware token. Is
Yeah.
that stored on the server, or is everything in the sent over?
Yeah, so it's CSRF middleware tokens are not stored on the server. So if you were to go look at the database, you're not going to find them in the database anywhere. They are generated, stored in a cookie, and then I don't remember exactly how Django creates the one that goes into the page to compare it against. What might be happening, and again, I'd have to look at the code to double check this, is like, if you don't have a CSRF cookie, it's going to generate one for you. But otherwise, when it's sending the page out, it's going to just copy whatever's already in the cookie into the HTML as well, right? So like, it's not perfect security because it's like, there's definitely reuse of cookies within a session, or reuse of tokens within a session, but it's not stored anywhere.
Wait, so then what stops an attacker from just making up both a cookie and the HTML thing and then sending that over?
So theoretically, nothing stops them, but let's talk about what the actual attack surface there is, right? It's like, if an attacker has access to the user's current session because of a cross-site scripting attack, game over already, right? Like, you're already kind of hosed. That sucks. If you're worried about them kind of like lucking into getting the right token to like impersonate a user, I mean, the random, that comes into like, how much do you trust the random function, which I think is just like pulling from dev random, right? Like, is it possible to have a collision from somebody else's machine arbitrarily? Yeah, totally possible, but probably unlikely and probably not something you need to guard against. If you're super worried about it, you could be checking authentication and CSRF, right? Like, and for most endpoints where somebody's submitting a form, you should probably be doing that already, because then then an attacker would have to impersonate. They'd have to like have caught the session cookie and the CSRF cookie, which if they can catch either cookie, they can probably catch both. And then they have to like, basically now you're talking about like a man-in-the-middle attack, right?
Yeah.
And man-in-the-middle attacks, the best way to prevent against them is to use HTTPS, right? So like, if your site is over HTTPS and you're using CSRF and you're checking for login tokens, then now you're getting into like, you've cut like 80-20 rule, right? You've done 80% of the protection that you can give them, and so you could maybe try to get that last 20%, but that last 20% is going to take 80% of the work because you're coming into like much higher security levels that are going to be harder to implement and harder for your users to try to manage.
Cool.
Other questions? About life, the universe, or anything? Django security? Working on Django? How much time? We have like tons of time left, don't we?
At least 10 minutes.
Yeah, great. I promise you right now that I'm not going to like laugh at your question or think it's dumb. If this is your first time hearing about Django, great. I want to talk to you and I want to hear your question. Like, I want questions.
You might not be able to answer it, but you mentioned that the SQL injection protection is separating the data from the query and it's done in the database driver.
Yeah.
Do you know how that works in the database driver? Like, how do you use that functionality?
So again, I'm not going to I do not recommend you try to access that functionality directly for your code. I mean, it's like if you have to use .extra or .raw SQL and you want to try to still make sure that you're like escaping things correctly and your database driver like publicly exposes their escaping methods, then that's probably okay. But from Django's point of view, it's just keeping the SQL statements and the code and the data going into the SQL statements separate all the way to the database driver. And it's the database driver's responsibility to combine them and do the escaping on the data so it's not being interpreted as code by SQL. Does that make some sense? If it's not clicking, I'm happy to talk more after questions. Yeah, one in the back there.
So with OAuth and all these tons of third-party services for authentication, do you have any recommendations for the good practices or risks using OAuth?
Cool. My primary recommendation, and I'm going to sound a bit like a broken record, is especially if you're authenticating with OAuth, please, for the love of God, use HTTPS because I think that OAuth is maybe a little susceptible to man-in-the-middle attacks, but don't quote me on that. My recommendation is to get you out the door, try to find a package that handles all of that for you. Unless you're like also running your own OAuth server, you're probably OAuthing against something like Twitter, Facebook, Google, Amazon, Yahoo, et cetera, et cetera, et cetera. And the reason I list all of these is because there is a great package called Django All-Auth that is kind of a just drop-in, plug-and-play package for doing both registration and social registration on Django sites. It supports some crazy number, like 30 different OAuth providers, plus I think has some functionality for accepting arbitrary OAuth providers. And it's the only Django registration package that I've seen that actually comes with templates. It's amazing. You can just it's not gonna look pretty, but you can literally drop it in and add registration to your site with like 5 lines of code. Did that kind of answer your question? Awesome, great. Anything else? Again, I'm totally welcome to answer questions afterwards. I'm gonna give a little shout out for something since we've got time. We've got so much time. Oh good, you can't see anything yet. There is this cool organization. So first of all, I am, like I said, I'm an employee at Eventbrite. We are definitely hiring. You should come talk to me if that's something that's interesting to you. If you're looking to do some volunteering, especially around some of the stuff going on with this election cycle, there's this organization called Dev Progress that's like tech volunteers for a political campaign that I'm not going to mention because I might get in trouble for mentioning it. But I work with this group too. Feel free to come chat with me because they're pretty cool. Yeah, I think that's going to do it. Oh, if you were trying to get the link? Yeah, great. Okay, great. devprogress.us. I think we're done. Thanks, everybody. This is fun. Let's do it again.